All right, I can't say anything. Can you?
No.
Anybody?
Nothing.
Okay, and that's how they're supposed to be. You should not be able to see anything through the glasses. Thank you for joining us as we prepare for the great American eclipse. Clouds are expected to continue limiting our visibility, but that won't stop us from having a lot of fun and enjoying a once-in-a-lifetime event for those that are able to tune in or that are tuning into our special 2-hour special.
It's a long time and we have a lot in store. We're asking the experts about this astronomical event. We're catching up with eclipse chasers and we're testing our own knowledge. We will be buzzing in with trivia answers.
With a Jeopardy expert too.
That's right.
Yeah, I know.
No.
I guess we call him expert. Yeah. Some of our youngest.
My glasses.
Yeah.
Okay.
Some of our youngest learners are also getting in on the action. Local students sent us several questions about this historic moment, and we'll provide those answers on air.
Yes, but we do want to get a check of our eclipse forecast, and as we've been talking about really since early last week, we were expecting mostly cloudy skies here, and that has definitely been the case. Looking at satellite, those up into Texas, North Texas, are looking at maybe a slightly better chance. They're getting in on some increase in cloud cover, but it looks like around the Dallas area, maybe not as bad, nor is it as bad across much of Arkansas. Certainly more breaks in the clouds where we have more of the better visibility, better viewing is up toward the Ohio Valley and then into the Northeast, just outside of our map here. So the good news is it does look like a lot of the within path of totality will have a decent shot of it. Not really in South Texas, but for Southeast Louisiana, unfortunately, it is not looking great. We also have some scattered showers around, a few thunderstorms, and that is just helping to add to our cloud cover. So not looking great. All we can hope for over the next couple of hours is to get a few breaks here in the sky, because at the moment, not looking too optimistic. Alexandra?
As we mentioned, the clouds aren't standing in the way of special events happening around town.
That's right. The Children's Museum of St. Tammany has a whole day planned for the Great American Eclipse. Our Meg Ferris joins us live from Mandeville. Meg, how's it looking out there?
Well, it is cloudy, and photojournalist Adam Kopis and I on the way over here on the causeway, we did have a few little sprinkles, but every now and then the sun, you can see the sun. So we'll just have to wait until that main part of it around 1:48 happens. But as you mentioned, I am here at the Children's Museum of St. Tammany. We're in Mandeville, and there's lots of activities going on. I want you to look behind me. So the children are here. It's usually not open on Monday, but it is today, and what they're doing is they're taking their glasses, because they have glasses here. They have about 50 pair left, and look what Aurora made for me. You color the crown, and then you tape that to your glasses so you have the glasses and a crown. And Aurora asked me what my favorite colors were, purple and like an indigo blue. She made me this beautiful eclipse crown and glasses, so I'm going to be wearing those when we go outside. But lots of children here learning about it. They have the NASA channel on, waiting for it. And what's so interesting is these activities are sanctioned by NASA. And I want to come over and talk to Julie, because Julie Mendez is you're the director here of programming. And you really have been working with NASA for a long time to get all this coordinated.
Correct. So we've been planning for about the past year. We participated in the annular eclipse in October, and then we've been meeting with them almost monthly on webinars to gather information. They share activities. We also have activities from it's called NISENet, which is a National Informal STEM Education Network, and so they've provided some of the activities here. We have a partnership with NASA called NASA Astro Camp Community Partners, and so we actually run their NASA Astro Camp here in the museum over the summer.
What do you learn or what can children learn, and can they still sign up?
So yes, they can sign up for camp. NASA Astro Camp is for ages 2nd grade through 5th graders, and then we do have a camp for younger kids. But during the NASA Astro Camp, we get all of the materials from NASA, and so they are learning about space challenges, STEM education. They'll get some free play in the museum, so there's lots going on.
That makes perfect sense. The reason I fell in love with science, we're watching the astronauts land land on the moon, and it made you want to learn all that. And you're right, things like this can inspire children.
Yes, so we try to get them hands-on, and we are trying to spark their interest in STEM. So if we can develop these fun activities that are getting them learning, they don't even know they're learning. They think they're playing and having fun, but they're learning lots of things through the process.
So what are some of the things, I know we're looking at the colors and the crowns being colored and the glasses, but what else did NASA tell you to do? I see a little boy over there we just showed that has the corona sticking out from the moon's shadow. What else did NASA have in the Arts and Crafts division?
Okay, so yeah, as you mentioned, they can make a chalk art of the corona. At the next table, we've got some pinhole projectors. So if you don't have a safe way to view the eclipse, you can make a pinhole projector by just poking a hole. If you don't have this activity at home, you can do it in an index card, and you can use the reflect the shadow on the ground so you're not looking up directly at the sun.
Okay, well, Julie, we'll be back with you. We'll be showing y'all more and more things, and I hope we're going to get outside to actually use our glasses that they have here at the Children's Museum in St. Tammany. And now, Chris, make the clouds go away. Back to you, Chris.
I'm working on it, but I like that little guy that was putting the suns over his eyes. That's exactly something I would have done. I don't know if you saw it, Meg, behind you. It was hysterical. Oh, you gotta love kids, because they're gonna ask some of the best questions, and we are answering some of those Eclipse questions from some of our local students. The first question comes from Lake Forest Charter School. Let's hear it.
My name is Denham Jones. I'm in 6th grade at Lake Forest Charter School. My question is, if galaxies rotate, why do they look stationary?
That's a good question. Denham Jones asking why, if galaxies rotate, do they look stationary? That's a good question. And we were actually looking at some of these questions last night. I'm thinking what she's referring to is looking off in the Hubble Space Telescope and looking off in the distance. Scientists have ways of seeing motion that may not necessarily be something you can see with visible light. They have various instruments that are allowing them to see what can rotate. I mean, they understand that our solar system, or our galaxy, the Milky Way, actually rotates, although we're in the middle of it. So they have very complicated ways. That's more of a question for definitely an astronomer as to why it looks like they are stationary. But definitely there is an appearance of some movement based on some of the tools that the satellites actually have. The satellites, and then the new James Webb satellite, actually gives us a much clearer picture of what is out in the universe. All right, Samuel Foreman wants to know, what phase is the sun in during a solar eclipse?
My name is Samuel Foreman. I'm a 6th grader at Lake Forest Charter School, and my question is, what phase is the moon in during a solar eclipse?
Okay, so that was actually a fantastic question. It is a new moon, meaning you cannot see the moon, because the way the Earth, Sun, and Moon are all aligned, the Earth's shadow, or not the Earth's shadow, but we are now looking at kind of the darkened part of the moon when there is a solar eclipse. So the phase of the moon right now today is a new moon. You can only get a solar eclipse during a new moon. All right, that question, we got another question. Let's hear this one.
How does a solar eclipse differ from other astronomical phenomena?
Well, there are a lot of different astronomical phenomena that come from Deshaun Joseph, a student at Orleans Charter, science and math. These are all great questions, and I tell you what, I was looking at these last night. Some of them I had to go, what does the old Google know? It differs. I would say it maybe is a little bit more interesting as compared to so many other phenomena in the solar system, in the galaxy, the universe, in that it's all pretty much in our backyard as far as the size of the universe goes. There are many different things. You can see the transit of Venus when Venus actually passes across the sun. There's an alignment of planets that you can kind of see in the night sky sometime. But I think what is really cool about both solar and lunar eclipses is that they're so close to Earth. That it's kind of a little bit more exciting, because these are things that are happening so very, very close to us, and it's not something that you even need a satellite to see. You can see it with the naked eyes, although again, use the protection for the solar eclipse. Peter Hamilton wants to know, does every black hole have the same size singularity?
Hey, I'm Peter Hamilton. I'm in the 6th grade and I'm from Lake Forest Charter School. My question is, does every black hole have the same size singularity?
Where's Itai? Does he know this? Where's our Jeopardy champion? Does he know this one? I'll be honest, as far as meteorology goes, we didn't look that far into the sky, so I'm a little, I'm not as on with my black hole science. That was really putting me on the spot. All right, our final question comes from Andy Tron.
Hi, my name's Andy Tran. I'm from 6th grade and I go to Wake Forest Charter School. My question is that what do galaxies orbit?
That's a really good question. Ladies, do y'all know what galaxies orbit? Do we know what they orbit? Well, actually, the Alexa and Alexander are actually orbiting the studio right now, getting into position.
I looked this up. I couldn't get a clear answer. I think like we have satellite galaxies that orbit our galaxy or something like that. Yeah.
Yeah, they do orbit kind of like the center of the mass, it kind of seemed, right? So that's kind of what I came up with.
It's not, it wasn't like a center of the universe at all. I mean, there are billions upon billions of galaxies, and it seems like there may be bunches that orbit kind of some kind of center point. So with that being said, let's go over to Alexa.
Yeah. These are some really good questions,
Great
definitely.
questions,
I know.
fantastic questions.
Definitely for
I'm
an
not smart enough.
Yeah, me neither. I had to look them up.
We need Google.
Yeah, we definitely
Or
need
an
to
Alexa.
talk to an astrophysicist.
We need an Alexa.
Yeah, you definitely need an Alexa. Not this Alexa, but definitely a different Alexa. I can call my friend from high school. Her name's Alexa Siri. Now she could answer the question. She's got 2 of the names. We're going to be talking to an astrophysicist soon, and nearly 13 million Texans are in the path of totality. So UNO astrophysicist Dr. Greg Schaub plans to witness the eclipse from Dallas. We're checking in with him now. Dr. Sieb, rather, actually. Thank you so much for joining us, Dr. Sieb. What's it like in Dallas right now?
Well, we're getting some breaks in the clouds and being able to see the sun, and we see the eclipse start. Yay! And so I've got high hopes of being able to track it reasonably well, and may even get to see the solar corona when we reach totality.
Wow, that is really amazing. Now, you have a very impressive background. Can you tell us a little bit about what you do at UNO?
Well, I'm in the physics department, and my degree says physics on it, although it's actually in astrophysics, because astrophysics is the physics of the stars and the sky and all of that. And so I've taught a lot of classes, intro classes in physics and astronomy, teaching and senior/graduate level course in introductory astrophysics. Just a lot of fun. My students are great. They won't let me get away with anything. They make sure that what I do is right and consistent, and I just love it. I'm going to miss it when I retire.
That is so awesome. So I was wondering, why do you think that this particular eclipse is rare? Because people say, okay, no, it isn't rare. Yes, it is rare. What do you think makes this eclipse so rare?
By the way, I could actually answer those 2 previous questions you had.
Please do. Please, don't make us look, we look bad. Please answer them, and then we'll steal your answers.
Sure, but if you want to know about the eclipse first,
yes.
You get eclipses often 2 or 3 times a year. It's just not here and not total. And so that is a pretty rare thing, even to have them within writing range like this is. And I've made a trek up to a relative's house in outside of Dallas so that I can have at least a shot at watching it. So there's lots of solar eclipses, and they come across, and somewhere in some very distant part of the Earth, like Australia or Antarctica or India, and just having one within any range of where you are that is a total solar eclipse is what's.
Now, you said you were able to answer some of those other questions. You heard them about the black holes and the singularity. Was that something you said you could answer?
Of course, I'm an astrophysicist.
Please tell us whatever you know. Keep it simple,
okay,
please.
well, the size of the singularity of a black hole We don't know because it's inside the event horizon of the black hole, and nothing can escape from a black hole, not even light. We don't know what happens inside the event horizon of a black hole. It's it's covered up. So is everything contract to an actual zero size, or is there some minimal size, or does it depend on the mass? The answer is a definite we don't know, which makes it a very good question.
Now, I know you probably get this question a lot, and I saw some of the students asked, do you think that there's life outside of our galaxies or in space? What do you think about that?
I like to quote from Carl Sagan and also in the movie Contact that if there isn't, it sure is a big waste of space. So I actually believe that there's life out there. It seems like such a natural process that it might happen anywhere. I do not, on the other hand, believe that UFOs are alien visitors. Because that just makes no sense whatsoever.
Well, thank you so much for joining us. Thank you so much for your time. Hopefully you have a great view of the eclipse. It was really nice to meet you. We are going to be taking a quick break. Make sure you stay tuned. We have a lot more coverage coming up in just a few moments.
I'm moving on. Hey, got nothing left to say. Let's be on my way. Best of luck. I'm moving on. I'm moving on.
On April 8th, 2024, a total solar eclipse will have millions of people across North America in awe of what's to come. That path of totality is going to enter into western Mexico and move across the United States into Canada, passing through Texas all the way through into Maine. Here in New Orleans, we will see a partial eclipse with 80% coverage of the sun. So, of course, what is a solar eclipse? You probably remember back to elementary school days. It's when the moon passes between the sun and the earth, either blocking it completely or partially. And there are 4 different types. There's the total solar eclipse, annular, partial, and a hybrid of both total and annular. So if you're in that path of totality, that is definitely something special. You'll see something there that you won't see out of the path of totality. So if you're in that path of totality, you'll see the sun's corona, which is the sun's outer atmosphere. It's usually blocked because the sun's surface is so bright. And this photo is back from 2017 during that total eclipse, because as the moon blocks the sun's surface, you can see that outer atmosphere, and it is truly a sight to see. It is going to be beautiful. If you're in that path of totality, of course, you can view it safely. You'll be able to see these very intricate, flowy kind of lines, also known as streamers and loops, coming out of the corona, only if you're in that path of totality. But here in New Orleans, even though we won't be in that path, we'll still see 80% coverage. So here's a rough idea of what it's going to look like, and it's going to look spectacular. So the partial eclipse begins around 12:29 in the afternoon, 12:29 p.m. on April 8th. That's when first contact happens, when the moon just touches the surface, the exterior surface of the sun. And then at 1:49 p.m. in the afternoon, this is roughly what it will look like here in New Orleans. Not bad, 80% coverage, we're almost there, so it's gonna look amazing. And then as it departs from the sun's surface, the partial eclipse will end at 3:09 in the afternoon. So the full experience from start to finish will be lasting 2 hours and 39 minutes. Of course, the maximum eclipse much shorter, happening at 1:49 in the afternoon. So here in New Orleans, we will see a partial eclipse with 80% coverage. And if you're wondering when the next eclipse is here in the United States, it's not going to be until 2045 when it goes from coast to coast. And New Orleans will actually be even closer to the path of totality with 90% coverage of the sun here. And Jackson, Mississippi will be in the path of totality then.
All right, and this is also an exciting time for local astronomers. We're joined now in our studio live with David Williams from the Pontchartrain Astronomy Society. And David, by the way, was kind enough to bring us these glasses that you see us wearing, along with a lot of other supplies for the eclipse. So thank you for that. And tell us, first of all, about the Pontchartrain Astronomy Society. Some people may not realize that we have this society in the New Orleans area.
Yes, the Pontchartrain Astronomy Society has been around since 1959. And I've been a member for many years, a former president. And right now we have probably around 100 or so members.
Cool.
And we have meetings once a month.
Yeah, and you guys have had some events. I remember going to a few in the past where you set up a big telescope, or, you know, at different events you'll do different kind of things for the community too. Yeah.
Right.
Very cool. And so David was actually there in Nashville, I think. Were you there?
Yes.
In Nashville for the 2017 eclipse. And he, you know, a lot of us haven't actually seen totality. It's all about totality, even though we have the partial eclipse, which should be pretty cool. It would be so spectacular to be in the path. So my question is, you've been in that path where it's 100% obscuration. How dark does it actually get? What did you think?
At maximum, it's probably around like twilight. Because even though the sun is blocked by the moon, there's still a glow, the corona, and it lights up the sky. But what's interesting is that the sky is dark, and then maybe around 10 degrees above the horizon, it's like twilight sky. But then it gets darker the further up you go.
Oh, interesting. Did you see some stars?
Yes, yeah. The star Regulus was very close to the eclipse of the moon and sun, and so yeah, the stars do come out. I mean, it gets dark, and then the temperature does go down. Sometimes there's a little breeze blowing, and it's just a spectacular event. It's something that I have never seen before, and it's something that you remember the rest of your life.
Oh yeah, and then I've heard also that, you know, crickets can come out, everything kind of turns to nighttime just for a couple minutes, and then it's back to the full sunlight. And interesting, so we have had a couple of other questions. Some people have asked, how does it affect weather on Earth? And you just said it. It can knock the temperature down, especially in totality, in kind of a noticeable way. Even here with our partial eclipse in 2017, the temperature went down 2 or 3 degrees briefly, just because so much of the sun was blocked. And then it can also change wind a little bit as well. It's not really long-lasting effects, but that does seem to be most of the weather effects that it has on Earth. Does the Pontchartrain Astronomy Society have anything coming up?
Well, there is a meeting on April 17th at the East Bank Regional Library. And that's the only event I know at this moment.
Okay, cool.
But, you know, we do have outreach events every so often.
Yeah, I remember seeing some pretty cool stuff at the Kenner Rivertown Planetarium several years ago. There was a big telescope set up. I was looking at, I forget what it was, something cool. There was some planetary kind of thing. Yes, and so actually, since you're almost finished with our interview in the studio, hopefully you could go out and see, maybe try to catch a glimpse of the eclipse right now.
Maybe. Because during the total eclipse in Nashville, there was a clear sky up until there was 2 minutes of maximum darkness, when a cloud rolled in and knocked out a whole minute of the eclipse.
Oh, okay.
One cloud.
Wow, that's enough to do it. And unfortunately today we have a bunch of clouds, so we will see. But you and I were talking on the phone earlier saying hopefully there will be a break, even maybe just with some cirrus clouds. You know, you were pointing out that you can see it through those high cirrus clouds sometimes, so we just need a little bit of luck, I think, heading into this afternoon. Yeah. David Williams with the Pontchartrain Astronomy Society, thanks so much for being here.
You're welcome.
Appreciate it. And now I believe we're going to go over to Alexa.
Yes, thanks, Alexandra. Now, we're also talking about safety. While the skies are pretty cloudy here in the New Orleans metro area, that isn't the case everywhere. So if you are heading somewhere with better visibility, protecting your eyes should be top priority. But if you're having trouble getting your hands on those special solar eclipse glasses, here is an alternative.
Solar eclipses have inspired people for hundreds of years and will continue to on April 8th. In the past, observing eclipses helped us discover the element helium and prove Einstein's theory of general relativity. So how can we check out this awesome show without hurting our eyes? Well, there are many ways to check it out safely, like specially approved solar eclipse glasses. If you do happen to have ones left over from 2017, they are still good to use as long as they're not damaged. And of course, regular sunglasses will not cut it. You will also need special lenses and filters to be able to see it safely through a camera, telescope, telescope or binoculars. If you don't have official eclipse glasses or those lenses and filters for your devices, another way to check it out is to find a tree and look down at the ground. With your back to the sun, look at the shadow of the leaves from the tree. You'll be able to see the crescent shape when the partial eclipse is happening. You can also do the same thing with a kitchen utensil with holes in it, like a colander. The sunlight will pass through the holes and you can see the partial eclipse while looking at the ground. If you want to get really creative, you can make a pinhole projector at home. First, you need a cardboard box like a cereal box or a shoe box. Then you need aluminum foil, a pencil, scissors, tape, a pushpin, and a white piece of paper big enough to cover the end of the box. Trace one end of the box onto the white paper. Cut it out, then place it into the same side of the box. Then cut 2 square holes on the opposite end of the box. Tape the middle if using a cereal box. Cover one of the square holes with aluminum foil. Tape the foil in place and use a pushpin to make a very small hole in the center of the aluminum. To use that projector, stand with your back to the sun. Then hold the large square opening up to your eye and look around until you see the sun projected on your white paper inside the box. The sunlight will shine through the tiny pinhole and cast a fantastic image on the white paper in the box. There are many other ways to check out the solar eclipse. Remember, do not ever look directly at the sun no matter what, because you can do permanent damage to your eyes.
We really want to make sure, first of all, of course, that we're accurate. That is huge for us as meteorologists. We want to do a really good job with that. And of course, we want to get the information to viewers in a way that's really clear and understandable, and in a way that can really help you decide what to do.
What we do here as a team at WWL, we try to make sense of all that uncertainty so you can make the decision to stay safe or do what you need to do for approaching storms or whatever the active weather may be.
There are folks out there that have that instilled fear of severe storms, the unknown of pop-up thunderstorms, tornadoes, as well as probably one of the biggest events in southeast Louisiana being hurricanes. And so I try and quell those fears by answering all of the questions that the public may have about these events. There's no way to avoid them usually, but if I can kind of answer those questions and put folks' mind at ease, I've done my job.
Really what motivates me to get up every single day is knowing people are safe and they know exactly what to do when the weather strikes.
It's all on the WWL TV app. Breaking news.
We're following breaking news out of Jefferson Parish.
Local weather.
We are expecting an active weather day, so make certain that you are weather aware.
Original stories.
It's a story you'll only see on WWL TV.
Impactful investigations.
Changes are happening after a WWL TV investigation.
The latest from the field.
We are live in Covington with...
And the Dome.
And it was a high drama day in the Superdome.
Download the WWL TV app.
While most of us look forward to the solar eclipse with excitement, some regard the celestial event as a bad omen.
The solar eclipse has been the subject of various myths and superstitions. Meteorologist Christina San Juan reassures us there's no need to be concerned.
Here's a widely popular myth that's still circulating to this day. Pregnant women should not go outside during a solar eclipse because of a special radiation produced that would harm the unborn child, leading to physical deformities, cleft lip, and birthmarks. Now, beyond the solar rays allegedly affecting expecting mothers, some believe it will also poison or contaminate your food, saying you must fast during an eclipse because any food cooked or eaten during an eclipse will be contaminated or poisonous. But as we now know, the rays emitted during an eclipse are not different from any other day. Just be sure to wear proper eye protection. Now let's talk about birthdays. Is yours April 8th or October 8th? A solar eclipse on your birthday or 6 months after has been believed to be a sign of impending bad health. But don't worry, there's no science to back this up. The science we do have now allows us to know what causes an eclipse, and it's not because a beast is attacking the sun or that the once fiery golden sun went out like a candle. Tribes in Peru would shoot flaming arrows into the sky with hopes to scare away that said beast. Now the Chippewa did the same, though their intention was to reignite the sun with the flames. Not all of these myths are about doom and gloom, though. Legend has it that if you plant flowers during an eclipse, they will bloom brighter and more colorful than they otherwise would. While these age-old superstitions may cast shadows of uncertainty, the light of scientific knowledge illuminates our understanding, allowing us to look forward with anticipation, not fear, to the rare spectacle that is a total solar eclipse.
Today is actually my parents' wedding anniversary, so it's, I don't know if it's a bad omen or not. 46 years, so they've been, going strong for a while. But I did find it interesting, speaking of, I think maybe misunderstandings as opposed to myths. There was a sign on the interstate that said, keep your headlights on during the eclipse. It's not going to be dark. About what it looks like now under the cloudy skies is about as dark as it's going to get here.
Yeah, and we were talking about it back in October. There was the annular eclipse, which was actually about the same coverage and expectation for our area as the one today. So there's so much more hype about this one because it cuts through a huge part of the U.S. and a lot of people are in that path of totality. But it's kind of funny for us. It's about the same. If you remember that in October,
it was, and it was like a sunny Saturday or Sunday. It was during the weekend. I had my kids out to go look at it. We had the glasses, but there wasn't a lot of buzz about it. I was trying to remember. I'm like, wait, I know we had the one in 2017, but I'm almost positive there was one more recent, but we didn't talk about it. Again, it's kind of this eclipse has a lot of good PR.
I know, right?
It's true.
You know how like the ancient cultures were afraid of it? It kind of seems like it's coming back. Everyone's like buying milk and bread. Like why? Why is that happening?
Really? No, and what you need is toilet paper. I mean,
it's true. Yeah, you heard of
that.
I
For the eclipse,
yeah. Speaking of the eclipse back in 2017, I was interested, like, what is the difference between that one and the one happening today? There are a lot of differences, actually. Now, let's take a look at what I found. You may remember back in 2017, all the buzz about that total solar eclipse happened back in August of 2017. So what is the difference between the one happening this year and the one that happened 7 years ago?
In 2017, there was a smaller path. Only 12 million people were in that path of totality. Also, there was less time in totality, so that maximum time was only 2 minutes and 40 seconds in Illinois. Also, there was less solar activity in 2017. So basically every decade or so, the sun's magnetic field switches, causing solar minimums and maximums. In 2017, we were near a solar minimum, so there was less solar activity back then. People could still see the sun's outer atmosphere called the corona, like in this picture taken in 2017 of the eclipse, what it was in totality. However, the corona looked more simplistic with a less active sun. In 2024, we'll get some major improvements that will make this look even better. This time around, we'll have a wider path with over 31 million people in totality. Also, we'll spend more time in totality, 4 minutes and 30 seconds in Mexico for that maximum time. Also, this time around, we'll be near a solar maximum, meaning higher solar activity and a more complex looking corona. In totality, you'll be able to see more eruptions of solar material and things called streamers, loops, and prominences within the corona. And the reason why the path is wider this time around is because the moon will be closer to Earth. So 99% of the United States will either see a partial or total eclipse, and here in New Orleans, we will see a partial eclipse. Also, another amazing thing is more research will be done in 2024. It will also build on the research that was done back in 2017. NASA and other academic institutions will study the sun's corona, how it impacts our atmosphere, which has an effect on our GPS systems and other technology we use here on Earth. They'll also look into how this impacts animal behavior, plus many other endless studies on this magnificent solar eclipse happening on April 8th.
So recap, how is 2024 different from 2017? We've got a wider path this time around, more time in totality, also with higher solar activity in 2024. We'll see even more intricate views of the corona.
The corona is the sun's upper atmosphere, visible as a pearly glow around the eclipsed sun during totality. Its shape is determined by the sun's magnetic field and is linked to the sunspot cycle.
My question is, what is the sun's corona and why can't we always see it?
Hi, this is Travis Martin at John C. Stennis Space Center. Now you asked, what is the sun's corona? Well, the sun's corona is the outermost parts of the atmosphere of the sun. And yes, the sun has an atmosphere just like the Earth, but you can't see it with the naked eye. You need special tools to block out the brightness of the sun so you can actually see it. Now you can see that either through special filters that we have here at NASA, or you can see it through the lunar eclipse. And once the moon is in front of the sun, you'll be able to see that halo or the atmosphere, the corona of the sun.
My friend and I were talking about the solar eclipse. She said that there might be a devil comet we could see during the eclipse. What is a devil's comet?
My name is Bradley Tyree at NASA's Stennis Space Center. During the eclipse on April 8th, a comet called 12P Pons-Brooks will be visible across the sky and will be located near Jupiter. 12P Pons-Brooks is often called the Devil's Comet because of a mixture of ice and gas that bursts from the comet in the shape of horns. During the eclipse on April 8th, the darkness will provide a great viewing opportunity to see the comet, and it will continue to get brighter all the way until April 21st. This comet is about the size of Mount Everest, and it hasn't appeared in our sky in 71 years.
I'm Mamani Garia, a 6th grade scholar at Lake Forest, and my question is, why does NASA study solar eclipse?
Hi, I'm Simone Wilson at NASA's Stennis Space Center, and my question was, why does NASA study eclipse? NASA scientists study eclipse to make new discoveries about the sun, Earth, and our space environment. Total solar eclipses are particularly important because they allow NASA scientists to see a part of the sun's atmosphere known as the corona that is too faint to see except for when the bright light of the sun is blocked.
What role does technology play in studying and observing the solar eclipse?
Hi, I'm Tom Rich at NASA's Stennis Space Center. You asked about technology, so you know NASA's going to do technology. So when it comes to the eclipse, there's going to be several things that are going to happen. NASA is going to send up sounding rockets to go find out how the atmosphere changes. And we'll also be sending up weather balloons to see how that happens. But one of the things that we really want to do is we want to get the citizens involved. And you can go to the NASA Citizen Scientist website to be able to go and find out how you can get involved with your technologies.
I wonder why you can see lights in space.
Hi Conrad, thanks for the question about lights in space. So when we look out at the night sky, we're actually looking at stars, at starlights. So if you think about it, the sun is actually a yellow dwarf star. So technically we could call that starlight, but it's just that the sun is relatively close to Earth, so it lights up our planet and it heats up our planet. But when we look out at the night sky, those stars, or those suns if you want to call them, are really far away, and it takes that light a long time to get to Earth. There are other objects in the solar system that we can see, like planets or different asteroids. We can see those because, or the moon, we can see those objects sort of, if you quote, lit up because it's actually the sun's light shining off of those planets. And that's how we're able to see those planets and other objects in our solar system. But thanks for the question, Conrad.
All great questions. I wanted to show you this live picture right now from Mexico. This is the sun in totality. This is a total eclipse of the sun in Mexico. You can actually see the sun's outer atmosphere. Those little pink kind of flares coming off there, I think those are called prominences. So you can see this wonderful image right now in totality. Now we are going to check back with our Meg Ferris. She's at the St. Tammany Children's Museum. Meg, what is happening out there? I know it's a lot of fun. What are the kids getting up to? What is happening in St. Tammany right now?
First of all, I am so envious of all the people in Mexico getting to see the full thing. So it's very cloudy, as anyone here in our viewing area knows, but the sun peeks out every now and then. And just a few minutes ago, everyone came out of the Children's Museum. A lot of them have gone back in and put on their glasses and got excited. And when you looked up, you could see kind of the bottom right-hand side of the sun having that big bite out of it with the moon passing in front. But Julie Mendez is back with me from the Children's Museum, and she has some interesting things, and unfortunately it's behind the clouds now. But Julie, show us this, what people can do with a simple whiteboard and a strainer.
Okay, so if you don't have any eye protection, one of the ways you can view the eclipse indirectly is through a pinhole projector. So actually some household items everybody has at home is a colander. And when it gets real bright, you can look down at the shadow, and it'll actually reflect the light source, not the holes. So it'll start to do whatever the eclipse is doing, and you'll see a crescent effect on the shadows.
And you put it on there a few minutes ago when the little peeking out from behind the clouds, and we could see it. Now, these clipboards that are all here, they say, I see, I hear, I feel, I smell, and they want children and even adults to put down what they notice. And this is a NASA project. Tell me about that.
Yes, so NASA actually collects a lot of information during the eclipse to record for history. And so one way is that there's a website called eclipsesoundscapes.org, and you can actually go there and report your observations. They want to know things: what are animals doing? What do the clouds look like? What's the temperature like in your area? And people are collecting this information all around the world. There's also an app that you can download, and it's called Globe Observer. And so those are two ways you can actually provide information directly to NASA.
And as you know, NASA has planes up in the air because they are collecting data, and those data will help them with many things. It'll help them, they're studying the corona, and that helps them understand about how solar weather can interrupt communications and satellite transmissions and different things like that. And we're at a time now where the sun is in its peak area. Every 11 years, I believe it does that. And so that's really interesting. They learn a lot from this. It's not just, oh, fun, look, there's a solar eclipse. So, and so it's, I'm sorry, we can't control the weather. It's all Chris Franklin's fault, but he knows that. But anyway, but that's just some of the things how NASA's getting involved and how we can actually help NASA collect data. And it was so cute. Little Aurora Seals, my new best friend here at the Children's Museum, she said, what does a solar eclipse sound like? And I said, well, you don't hear anything. And she pointed down and she's like, Meg, look, it asks you for what you hear. And you were explaining that when they go in total darkness, some of the crickets and some of the insects will chirp. That's how they call for a mate when it gets dusk, so they won't get eaten. And some of the other animals will, run off or do something different. So, see, I was steering Aurora wrong, Julie. And anything else we need to tell people this time? We're going to come back a little bit. Anything else?
No, just keep your eyes peeled for those breaks in the sun, and hopefully, even if you weren't able to secure eclipse classes, you can use some shadows and observe the eclipse that way.
All right. Well, that's it from here in Mandeville, and we'll be back in the next half hour to bring you an update. Reporting live from the St. Tammany Children's Museum, I'm Meg Farris.
All right, thank you, Meg. This is a live look, I believe, still out of Mexico. This is from NASA. So in Mexico right now, they are under totality. Yes, in Mexico. They had reached totality at one of the towns, but of course it is passing across a good portion of the central and northeastern part of the nation there. So as the moon continues to pass very quickly over Mexico, you'll likely see the kind of what little bit of sunlight is left there will quickly close, and we'll start to see what Alexa was showing you, those little prominences, almost looks like little flares, little mountains on the edge of the sun, where, again, scientists are able to do a lot more analyses of the sun during the eclipse, only because it covers up such a large portion of this is in Temple, Texas. Boy, that's, again, this is about the extent of what we would see here. That's, actually probably is a little bit more than what we would see here in New Orleans if we were to get some clearing in the skies. I was looking at visible satellites, still not looking very optimistic for us. But certainly it's going to be a really cool sight to see across the entire path, and hopefully more of the states start clearing out a little bit.
Yeah, and I think that's the city in Mexico where the longest totality is going to happen in over 4 minutes. So that is really special. Oh my God, it's something really special to see, because the next one isn't for many years down the road. I think the next one from coast to coast in the USA is until 2045. And we were talking about path of totality in New Orleans way in the future, like what, 2050 something?
I think that one was 2078 for
boy.
New Orleans, and then, as you pointed out, the Grand Isle one is in 2052. And by the way, you may have seen that the next total eclipse for the U.S. is in 2044. Right. That's a year earlier than what we've been saying, but that one only covers a tiny part of the U.S. It's mostly kind of Edmonton, Canada, places like that, and then like a tiny little swath of Montana that like is completely unpopulated. So unfortunately, that won't be one of these big grand events like we're seeing right now and like we did in 2017, although this one covers about twice the population than the 2017 one did. So really this one is, you know, more people for sure in the path of totality this year, not to mention the 3 million or 4 million people traveling to the path of totality.
Right, well no, and I'm sure a lot of folks have seen it, that Airbnb map of the occupancy throughout the path of totality. That they're at 100% capacity of all these Airbnbs from the Texas state line up toward Maine. As it was exciting to see, because it's just more excitement of science and astronomy, and it's moments like this for kids. Meg was talking about that. It was moments like this for me that just got me fascinated by science. It was a little disheartening to hear so many schools kind of sending the kids home and they may not be appreciating what's happening. And again, we're not in totality in New Orleans, and I do understand the safety of not wanting kids to look up at the sun and damaging their eyes, but this is such a great experience that may get a lot of kids interested, and even adults start asking questions about, well, what is an eclipse and how does it even work? Why don't we see it every month? Why don't we see these more often? Why do the paths always change? How are they easily forecast? That was something we were kind of joking about. I think we're going to talk about a little bit later on about how we know already 100 years into the future. Actually, I think there was a graphic that maybe you showed that we already know to like the year 3000.
Yes, it's unbelievable.
That these can be well projected out into the future, that we know when they're going to occur, the path they're going to take. And it's just, it answers a lot of questions that maybe you haven't learned since you were in grammar school for some of the kids. So this looks like we are now at totality in central Mexico right now, and just incredible to see.
Yeah, that's really something. And by the way, Alexa was mentioning the longest, one is going on right now, and then it gets a little bit less and less. It looks like the farther north you go. So the maximum for like Texas is about 4.5 minutes in some spots.
That's pretty long.
It's pretty long. And then even in Canada, some spots will see it for more than 3 minutes. And actually both of those were longer than in 2017. Totality was up to about 2.5 minutes with that last eclipse 7 or so years ago.
So this is a big, it affects more people, or more people will see it. I hate to say affect because it's not really affecting. But more people, more of the populations will see it. And we have shown those maps of just how many of the large U.S. cities are within the path, so it makes it easy to view. And then also the duration, as you said, this is something that can be experienced. So I would expect that, from the astronomy standpoint, you're going to get a whole lot more research being done now on solar astronomy because of this length of totality.
Yeah, we wanted to bring in our astronomer here to ask you some.
And also, I'm
sorry.
go
No. I'm stealing your astronomer over here. I want to know some more information. So what can you tell us about this? I mean, how much can we learn from an event like this?
Well, we can learn a lot, and that's why NASA's sending up rockets into the atmosphere and such, into orbit, to study the eclipse. And I mean, the size of the sun could be refined. I mean, there's just a whole lot of information that could come out of an eclipse.
Yeah.
And we're going to see how much the temperature varies.
Right, exactly. Now, what kind of, I know animal behavior can be impacted by this, other things like that. What do you hope, do you think there's going to be any big discoveries that will come from this, as opposed to maybe the last one that we saw?
Hopefully, and there's always going to be something learned.
Right.
It's just, what is it going to be? That's the thing. We don't know yet. But with all of, we learned a lot from 2017, and now that there's improvements with different experiments and such that's going on now to better answer the questions that we had from 2017. So we'll get some answers now.
Was there anything you personally were looking forward to most with this eclipse?
Just seeing totality.
Yeah.
But being that I couldn't, unforeseen circumstances, I couldn't be there, but if I was there, I wouldn't be here with you all.
Yeah, that would not be good.
We understand.
We understand, but then we couldn't get these very important questions answered. But it is an amazing sight to be able to see the outer atmosphere, the corona. Something that I was learning a lot about in just the last few weeks. Just so much you can learn from it that has a lot of impacts on our GPS, our navigation, our other communication technology. So they'll be able to maybe improve that. I know everyone's always worried about that kind of thing.
And David, in the last one, you know, there are these things that they say to look at, you know, the diamond ring, the Bailey's beads. Did you see all that when you were there in Nashville last time?
No, I did not get to see the diamond ring because the one most important thing is the very first time you see a total eclipse, you just want to look at it with an unaided eye and take it in. Of course, you know, during the totality, you don't need to have the eye protection. But then near the end of the eclipse, you got to really have your timing down to know when to put the glasses back on.
Right.
So, but yeah, but I mean, it's nothing like totality.
Yeah.
Right, and for New Orleans residents in, you know, our lifetimes, we've never seen one. We've had several of these partial, and they're neat to see. It's kind of fun to see that crescent shape, but it's nothing like the experience of being a total. That's why I kind of laughed at that sign on the interstate of keep your headlights on during the eclipse. I don't know if people realize it's not really going to get very dark here. I remember in the one last October, it almost looked as if a cloud was passing, you know, over the sun, and kind of that filtered sunlight, that was about as dark as it gets, just like a cloud passing overhead for us in the partial. And then the totality is what is just that, what people have said, almost kind of an eerie calm where everything, it seems to, you know, go to night all of a sudden, and the animals start, or the insects start chirping, and it almost seems like a few minutes of twilight before the sun starts coming right back out.
Yeah, and I've heard people also describe it kind of like just almost a filter over the sun, or as a cloud, something like that, just something where it's not quite as bright as normal. But it's kind of crazy that you can cover up about 80% of the sun, and it still just looks like maybe a little bit of a cloudy day.
It is still bright sunshine even at 80% coverage.
Yeah, and so I think this is now a shot from Arkansas, or this one is now in Texas, I think, Junction, Texas, it's saying.
It looked like it was Junction, Texas, because it is nearing the Texas border now.
Right, and I think Little Rock starts at 1:51 p.m., so we're kind of getting toward that part of the, you know, kind of more northeast kind of part of the track.
You know, I know we're not in path of totality here, but I saw that you can actually remove your eclipse glasses in totality. Is that correct?
Yes, during totality, you don't need eye protection.
Okay.
But it's timing it right.
It's the timing when you, you know, take them off and put them on.
Yeah.
I guess there's that caveat of we're telling you don't look at the sun, don't look at the sun. In totality, with those few minutes, you can, but be real quick to get those glasses back on.
Right, and don't linger like you were saying, because once it starts to peak out, it's already kind of too late. You need to have them on
the first time you see a total eclipse, you do not want to be taking a lot of pictures and stuff. You want to be looking at it because a lot of times things go wrong and you're looking down and then the eclipse is over and you missed it.
Yeah, and that's a lot of questions we get. It's like, can we take pictures of it? Can we use our cell phones and things like that? But like you say, there are going to be plenty of those pictures out there from professionals. You know, just enjoy it if you can, you know, with your glasses safely, of course.
And our max eclipse time, 1:49. We're getting close.
We are getting close.
I wonder how.
Just wish we could see it.
I know.
Just wish we could see it.
It's like the clouds are getting
I don't know
thicker.
if I would go to our sky camera because there is not. That's not looking too promising at all. I know Austin. We're actually going to be talking a little bit later to my sister-in-law who lives in Austin, and while they are under mostly cloudy skies, she just sent me a picture on her phone. Hopefully, she didn't burn her lens. She can see it. So there may be getting some more breaks in Austin, because I know a lot of folks that went to Austin or some of those suburbs to see the eclipse, and it looks like maybe they're getting some clearing or at least enough breaks that they'll be able to see it. And then I was just looking, the Indianapolis Speedway has opened up, and they're allowing the path as well as the stands open for folks to come and watch it in there.
Ah, that's nice. I know, such a shame if you're going to travel to totality and then you get cloudy
Well,
skies.
and you know, it's funny because a lot of folks have been asking, hey, we really want to go see it. Where should I go? And I said, you're better off toward the Midwest. Texas, you're going to have that. It was kind of a iffy if they would get some breaks. There have been a slightly better chance from Dallas to Little Rock, but I said it's looking more likely to have it from Indianapolis, Cleveland, and then into New England as to having, but I don't know if folks were that gung-ho about going to see the eclipse and to travel that far. And again, you know, it being so close to New Orleans, you know, just an easy drive to Austin wouldn't have been bad, but hopefully they get, because I know there are a lot of New Orleanians in those suburbs, and I'm hoping they'll get the clearing to see it. I'm sure we'll start getting a lot of pictures on social media.
Yeah, and you have to think, even if it's a cloudy day, I mean, with the sun turning to twilight, you know, you're still going to see some effects. It's not going to be
yes, it will
drastic,
get, in the totality, it'll still get dark. Maybe you won't be able to see it, but just hope for the best. We're always trying to find that silver lining in the cloudy skies. Been great if we had a big dome of high pressure over the central part of the nation. Everybody was sunny, it would have had any issue, but of course, that's just not the way.
Yep. Did you see that thing today that people were skydiving in the path of totality? Like, we ran a story this morning. People were doing like you're jumping like 1 minute before totality with the glasses on. Did you see this? How are the glasses not going to fly on? I guess they're under the goggles.
I don't think they thought that through.
Yeah.
Wow.
Yeah.
It's funny. People are like, this is something that only happens rare. Let me add something else very rare to it.
I know.
I guess I don't feel that need. If I just saw it, that would be really cool.
Now, for it's also cool to see in the totality from an aircraft. Like if you're flying in, you know, in the path, that'd be kind of a neat thing to see.
Yeah.
I don't know if I need a sky jump. I don't know if I need to jump out of the plane again.
I heard that Whitney Miller, our anchor, was telling me last night that she's going to be getting off just in time to see it. So she'll be flying during like the partial eclipse.
Really?
No
into
way.
Ohio, and then she's going to get off, and I gave her some glasses because I was like, oh, you're going to need these. You can see the almost full path. I think it was going to be like 98% or something where she was. So yeah.
That's awesome.
Yeah, something kind of cool.
You know, this morning Eric Paulson made a good point. He's like, it probably looks cool from the International Space Station to see that shadow go across the Earth.
That's true.
Yeah.
If they're in the right position, they would be able to see it if they're on, you know, this side of the Earth at that time.
True, yeah.
Well, every 90 minutes, I believe it goes around the Earth, so they would have that window to see, although they have to also be passing over North America.
Yeah, that's true.
That could be cool. Yeah, and I think that was a shot from Arkansas that we've had up for a bit. Oh, this is Dallas, okay. And it's nice to see, it looks like some people in Dallas are able to see it.
Yeah,
so
I mean, we were talking about how many
that.
folks from here were going out there to see it, so it looks like maybe from Austin to Dallas, they were getting a decent window of clearing to see it.
That's really nice, and so many people, you know, in that part of Texas, so yeah, they'll be able to see it too. It looks nice.
I was going to say, should we play the game? How old are we going to be in 2052 when the solar eclipse passes over New Orleans? Or
2052, we'll be fine, right?
Like still alive?
Yeah.
I guess, you know.
Well, alive, yes. I don't know what kind of condition we'll be in 2052, but
if we're lucky. Yeah, the one in 2045 is 21 years away. 52 is 28 years.
Okay.
Yeah.
You kind of forget it is the year 2024. We're not that far removed from the 2050s.
That's
true. We're actually closer than we think.
That's a good point.
The 2078 one, though, 54 years away. So
say 54. I'm 42. So yeah, I mean, might be wheeled out and not know what's going on, but hey, I'll be here. Maybe.
Strap the glasses on you.
You know what's interesting is the one in 2052 passing directly over Grand Isle.
I know.
What do you think the Visitor Bureau of Grand Isle is going to be doing? I mean, they only have to plan for the Tarpon Rodeo every year. 2052, I hope they're already making their plans now. Pensacola, Destin, I mean, these are going to be huge destinations. And Leeville, Louisiana.
Yeah, and all like this one is very easy for us to get to. And like Alexa was pointing out, Jackson, Mississippi in the 2045 one.
Yes.
I mean, it's not far.
No, that's an easy. That's a day trip.
Yeah, and Destin and Orlando and Miami, very popular, you know.
Oh, and Destin too, yeah. So, you know, if you miss this one here locally, you're kind of not looking great for the rest of the afternoon, but, you know, 2045, Jackson, Destin, and you'll be able to see it.
Just make your plans 21 years out.
Just, you know, start booking those Airbnb. If Airbnb is still around in 21 years, I don't know, might be out of business by then.
Yeah, what will it be by then?
I don't know, who knows, right?
Might be flying cars at that point.
Yeah.
All right, so this is a live look. This is from Dallas, so they are nearing totality. What is the, do we know the peak time in Dallas?
I do. Let me look it up really quick.
They're certainly getting close.
Yeah, give me 1 second.
And you're going to have probably a similar look to the sun in Austin.
Dallas totality begins at 1:40.
Okay, so they're about
Central
9 minutes
time.
away.
They are close. Yep. Very exciting. Then it moves, of course, to Oklahoma. You get into Arkansas. For Kentucky, it starts around 2 p.m. And then you get to Cleveland, that's at 2:13. So it's kind of funny, that's in Central Time. I translated it 3:13 Eastern Time. So it's interesting. It's 1:30 right now. I mean, all these populated cities, even into the Midwest and the Northeast, all of them are going to see their totality start within the next hour or so.
Right. I mean, it is quick. It doesn't last for very long. The shadow moves very quick. And also, you know, for a scientist, it gives you an idea of just how fast the orbit of the moon is, and you can kind of calculate it. Throwing a little bit of math in there, you can make calculations based on how fast the shadow is moving across the Earth.
Yeah, very true. Yeah.
I'll let you work on those numbers, and you get back to us at the end of the segment.
I know, right?
That's my job. Okay.
Yeah.
David, would you like to do that?
Yeah.
Right. You want to start crunching the numbers?
Yeah. Actually, the shadow, when it's going across Earth, when it was entering, say, Mexico into Texas, it was traveling about 1,500 miles per hour. By the time it reaches the Northeast, it's about 7,000 miles per hour.
Oh my God. Interesting. Okay.
Wow.
So that accounts for the lower time, you know,
Yes.
that's spent in totality the farther north you go.
Yeah.
Wow.
Looks like Kerrville, Texas is in totality now as they're. Looks like the camera almost went black, so they have to kind of iris up to let in as much light as possible.
Wow. Those are those Bailey's beads, you know, that you've heard about, those little you know, dots on the side, you know, what did you call them?
Prominences. There's so many different names. There's like streamers, loops, prominences,
Right.
Okay.
solar flares, coronal mass
Right.
ejections. What you just said, Bailey's beads. Like, oh my God, how do you keep track of all this?
Yeah.
And you can kind of see what looks to be maybe some low clouds or high clouds passing. It's hard to see what type of level the clouds are in. But definitely still some passing clouds in Texas. But at least it looks like enough clearing for viewing. And I believe, do we have my sister-in-law? Molly? Molly? Are you on the phone with us? Maybe the eclipse took her offline. Molly, are you there? Is Austin still around? I was hoping to get just a civilian's perspective of what they're seeing on the ground. Molly, you there? Maybe we'll try and get her.
Maybe it does mess with things now.
Yeah, well, you know,
Could be.
it's
You know
possible.
what? They say
That's why we're doing all this studying right now.
That's true, yeah. They said it could mess with our communications.
So parts of Texas already in totality, moving up toward Dallas, and they will be in totality in Dallas in about 6 minutes, or maybe even a little less than 6 minutes now, as that will continue up toward then kind of Hot Springs, Arkansas, Little Rock, some of the larger cities we've been talking about as being destinations for viewing the eclipse, and then continuing up further through the Midwest.
And we kept pointing out New England and Maine. It's like the one spot where you're pretty much guaranteed to have a great view of it.
Yes, Burlington, Vermont, and up toward Bangor, Maine.
Looking
a lot
good.
of western Maine is kind of unpopulated, wooded near the Canadian line.
Yeah.
Maybe that may be the best viewing. Just away from people, out in the middle of the woods.
Yeah.
Just you and a moose.
That's true. That's
Molly. And speaking of that, Caribou, Maine starts at 2:32.
Oh.
Yeah.
So there's Kerrville, Texas. Hello. Hey, Molly.
Hey, can you hear me?
Yes. How are you?
Oh my gosh. How's it going? Good. How are you?
Good. So this is my sister-in-law, Molly Mulhern, and she is in Austin, Texas. So is the clouds, you sent me a picture a few minutes ago to where you could kind of see it. Are the clouds broken enough that you can see it?
So the clouds have been super, super patchy. So we've been getting glimpses of her being the sun and the moon. Right now it's super, super dark. Oh gosh.
Oh really?
So
oh, you hear all the cheering?
I'm looking at it without the glasses and I can see better, but I probably shouldn't be doing that.
No, well, if you're still in totality in Austin, it's okay to look at it without glasses, but as soon as the sun starts to break through, as the moon passes, you'll want to put those glasses back on. I don't want you blind.
Oh my
you're
gosh,
you're getting
so
married
dark.
on Friday, so I don't want you blind for your wedding.
It's gone.
The sun is gone?
It's completely gone. I can't see the sun anymore.
How cool is that?
It's like dark outside. Oh my gosh. This is crazy. Somebody play the song.
You're gonna.
Wow.
All right, so this is what,
amazing.
This is what. Well, you
It's
can't
so
see
dark.
it. We are seeing in New Orleans. We've got mostly cloudy skies. We're kind of hoping for a little break, but of course, visibility here is.
This is so crazy.
Yeah.
So this is what you want to hear. That's
is
what
great.
you.
Yeah.
I'm expecting this is the mood of
it's
all
like it's literally dark
Americans
outside.
from Texas to Maine throughout the afternoon
Crazy.
of how cool it is to be in totality.
Must be overwhelming. You can hear the people in the background
gosh.
even. Yeah.
Can y'all hear me still?
Yes, we can.
Keep talking.
Well,
Sorry,
no,
I'm
we
just
love
so shook.
hearing
I've
your
never seen it become
enthusiasm
completely
for seeing
dark
it.
outside in the middle of the day. So this is such a surreal experience right now. Oh yeah, the automatic lights in our apartment complex turned on because it's so dark.
Oh, no kidding. Do you have other neighbors out there looking as well?
What did you say?
I said, are other neighbors? You're in an apartment complex. Are other neighbors out there looking?
Yes, everybody's out in the parking lot, just like staring at the sky. It's like very, like the end of the world almost.
Well, it's not. I mean,
strange.
that myth has been debunked. It's not the end of the world. So you could.
Oh yeah,
again, they're
it's just
crazy
so
in
quiet.
Austin.
There's no more like the birds stopped tweeting.
Really? Now, are you hearing like crickets or insects?
I don't hear any crickets or insects. I hear the air conditioner. It's crazy. It's so quiet and dark. Okay, it's coming back.
Yeah, it doesn't last long, and that's when you'd have to put your glasses back on.
And you're looking at Kerrville,
Okay, yeah,
Texas,
well,
by the way, right now.
Yeah, the clouds are. I think it's just the cloud coverage is so thick that we're kind of seeing it briefly come out. So it's coming back around now. It's like a little tiny pinprick in the sky. Like it looks like a star right now.
Right.
Wow.
Wow, this is crazy. I logically knew this was going to happen, but then it's happening, and I'm like, wow.
Well, and that's what we've been talking about, that it really, even, to see at 80% coverage, 70%, it's neat to see, but it's a completely different experience to be in that thin path of totality. And it just so happens that this eclipse is covering a large portion of the United States and so many major U.S. cities.
Wow, and for our camera,
So there's
what
a
you're
tiny
looking at-
sliver now, and it's like, it feels like dawn. Like there's so much more light already, but it's not completely back yet. I'm putting my glasses back on though.
Yes, please put the glasses back on.
What we're seeing is Temple, Texas,
yeah,
by the way, on your screen.
It's getting lighter outside now. There is a cloud covering it, so I have a feeling once this cloud moves, it's going to get even brighter. Yes, it is brighter. It's like, wow, it's so crazy.
Well, you just heard Molly. I mean, just a few minutes ago, it sounded like she kind of told us the moment it went into totality in Austin. And we're looking at a camera here in Dallas, and they're probably about a minute away from totality there. So that was roughly, what, 5 minutes, and not even that, maybe 3 minutes between Austin and Dallas to go into totality. So that's just how fast, how quickly the shadow is moving.
Yeah, and don't forget, for us, we're 10 minutes away from our maximum right now. I mean, obviously with the clouds and stuff, it's not as exciting, but we are just 10 minutes from max in New Orleans.
Yeah, we're seeing a little crescent again from the sun, so it's coming back, but wow. I see why people traveled here and why we're told to stay off the roads today.
Well, and tell us this, what were folks and maybe government officials and the media telling residents of Austin to do during these couple of hours? Were schools canceled? Were people told to stay off the roads? I mean, what were they doing?
Yeah, so I know that UT Austin canceled classes today, or like had them remote. My job was remote today, and pretty much the consensus was, if you don't have to go anywhere, don't, especially right now. But the real reason is also the traffic, because millions of people traveled here to see it. So, and I understand why. Wow, it's getting bright again. The automatic lights are turning, they're still on right now, but.
And as it's getting bright there, we're seeing Dallas, Texas, and
about to go dark, right? We're looking at a live camera in Dallas, and they are seconds away from going into totality. So it's already, the center of that shadow has already passed Austin and is now moving up toward Dallas right now.
Wow. Yep.
Wow, that's so cool. So they have 100, do they have 80? They have less than 100%?
They're at 100% as well. So you had two major Texas cities, Austin and Dallas, all within the path, almost the center of the path. And then you have Little Rock, Indianapolis, Cleveland, Bangor, Maine. You've got a lot of large cities that a lot of folks are traveling to. But it does make sense for the number of people that probably have come in town to Austin to see it. You want to keep those people off the road. I know Fredericksburg is what, not too far from Austin. And I know a lot of folks that I know, some neighbors that were headed there, just kind of the surrounding suburbs of Austin to see it.
Yeah. Yeah, the birds are tweeting again.
No kidding.
So.
Oh, good.
Oh, phew. All right. Austin is still on the map. Thank
The
goodness.
birds are not stressed anymore.
We didn't lose Austin.
The birds are okay. Awesome. Well, we're going to go play Whitney Houston Total Eclipse of the Sun probably now.
All right. Thank you, Molly. Molly Mulher, my sister-in-law, live for us in Austin. Thanks so much. And actually, I'll see you this week.
Yeah. Thanks for having me. Bye, y'all.
Bye.
Bye. Bye.
So that is, it's actually funny to hear it from just a non-scientist and the excitement of, yeah, we kind of knew it was going to happen, but boy, seeing it in its totality is something that is amazing. Yeah. So, you know, some folks were a little questioning, I can't believe people are driving out to see this. And I said, you know, it's something to experience. I've never experienced it. I want to. Maybe I have to wait till the one that's in Jackson or that passes over New Orleans or Grand Isle. But it is, as you heard, really just almost
it's amazing.
Unworldly to experience that. For those few minutes, you go from sunshine to darkness, and animals kind of respond. She said the birds got quiet. It got kind of eerily quiet around, and everybody was looking up at the sky, almost like a sci-fi movie,
yes.
you know, disaster movie. Everyone looking at the sky, and thankfully nothing happened.
Yeah, that's a good. I like that word you said, like otherworldly.
It is. It's just probably kind of an eerie feeling. I've heard some scientists describe the sky as going almost like a silvery purple. It's just something that we're not used to seeing. Something that is just not.
Yeah.
Is something that, you know, I mean, very few people actually get to experience.
Do you all think there's anybody in this path of totality who doesn't know this is going to happen today? We're just like,
We're not in the path of totality, and we've been talking about it almost ad nauseum. So people, I mean, in the news, are like, all right, how much longer are you going to talk about this eclipse every day? I'm like, every day until it's done, we're going to be showing that forecast.
Yeah. 3 o'clock this afternoon, we'll stop talking.
Yeah. For the 5 o'clock, we won't say anything about the eclipse. Although I will show a visible satellite to show you'll see the shadow going right over.
Oh, yeah.
We talk about how visible satellite is basically a picture of the clouds. It uses sunlight. You will see that shadow pass across the central part of the nation on visible satellite.
Pretty cool. And I wonder what we're seeing outside. You know, we're in the studio. We're only like 5 minutes away from what we consider our maximum here in New Orleans. Probably, I mean, our cameras are showing a lot of clouds, but our last shot, I did see for just like a second, I saw a little crescent of the sun on our camera that we have for WWL, but I'm not sure if we're still seeing that or if it's just a cloudy day outside, but you might be able to see a little bit of that like I did just a few minutes ago, but
that's not a live picture of New Orleans.
Yeah,
that I believe is still Dallas, who is under the totality right now, and I'm kind of looking at monitors off air of what's going on in Dallas, and they're showing the temperature dropping, and they're at least looking at the thermometer, and folks. You know, this is what gets you excited about science. Science is something that needs to be experienced. That's why we had mentioned earlier it was a little disheartening to hear schools letting them out, and I do understand the safety, but this is how you learn. I know my daughter's school, they're giving all the kids glasses. Of course, you're not really going to see anything, but they were also doing space-themed snacks. They were doing moon pies and sun chips. And as a matter of fact, I tried to get for a demonstration in studio a moon pie. I could not find a moon pie anywhere.
And there's the diamond ring effect. Look at that at Dallas.
Now that is cool.
What's that?
Yeah, it's just showing up. This happens when you go into totality and then right when you come out. And yeah, it's one of those cool things that you can see, right, David?
Whoa.
Like between two mountains.
Right.
It's going through, right.
Right, and just showing up like one really big, and the ring, of course, is the ring around, and then like the diamond would be that big. Well, it's one of those like Bailey's beads that we were talking about. So yeah, that just shows up super bright. So I love that shot of Dallas also, not looking at the sun, but just looking at the city.
Yes,
you know?
of it in that kind of you wouldn't.
Yeah.
Oh wow! Wait, that was another shot of Dallas. It was that much brighter. Okay, so just with that small portion of the sun back out, you saw how much brighter it already was.
Yes.
So that's why we were joking, even at 80% coverage, how bright it still is here. I mean, you walk outside, it's, that's us live. This is why we're not showing you New Orleans very much.
What a
We
shame.
unfortunately can't see. Again, if there's an occasional break, I keep glancing over at our visible satellite, but what's actually interesting? I'm looking at our visible satellite. I don't know if we can show this. We're losing what looks to be almost like it's going into sunset. but it's the path of the, I'm going to widen it out. If we can go to max 2, I don't know if we can pull that up real quick. You'll also start to see, and it's, I apologize, it needs to kind of load some of the images here. You will watch the path of the shadow. It's kind of loading some of the images here, so just give it 1 second. It's processing a lot of data, and that's the path. That is what it looks to be. I glanced at it, and
wow.
Looking, I went, wait, we're not losing the sunlight. Yeah, I'm like, oh wait, yeah, that's the eclipse.
Oh, wow. This is going to be a cool time lapse later.
This will be a very cool time lapse.
Moving
Look
across
at that.
the U.S. Yeah.
So yeah, that is the shadow. So as we've said, the visible satellite, this really gives you an idea of how that works. It is basically taking a picture, and it needs sunlight to see those clouds, but if it loses the light, then we lose the images. That's why we don't use it at night. And if there is an eclipse, we're also going to lose the imagery then too.
Yeah, so cool. And if you were watching just a few minutes ago for Dallas, when it seemed to be coming out of, totality, and it looked like dawn,
Yes.
It looked like very, very early in the morning.
Yes, that was very cool.
Yeah.
Now, where is this? Is this Arkansas?
This is Arkansas.
Okay, wow.
Yes, and they're really close, if not at totality in parts of Arkansas. For example, Little Rock is going to be in about 4 minutes, 1:51 p.m. It starts totality. So very, very close there. And again, for us, we're at about maximum right now. Not that you can see it, but this will be the peak.
2 minutes.
And it's funny, we're talking about it just to visualize the size of this. I'm looking at our visible satellite. Yeah, I mean, New York and the East Coast are already getting into the shadow. So this is, I mean, the shadow of it. And I guess to give you a better idea of just what this looks like, we kind of show you that thin path of totality, and yes, that is where it's going to be at maximum, but outside of that, almost the entirety of the nation is seeing some portion of the shadow come across. So I mean, the fact that it is almost bisecting the nation is incredible, that nearly everyone in the continental United States can see a portion of the eclipse.
Right, I think it was every single, the 48 states had at least a partial eclipse, and then I think it was 13 states where they have the totality crossing, and then like 2 slivers of states elsewhere. But yeah, huge chunk of the U.S. I mean, I guess that's why this one is such a big deal over these really big cities. It's a wider path. It's lasting for longer. Yeah, hence the hype.
And I know we've talked about the rarity, and I don't know if we have a package that we'll still go to, but you think the Earth is 70% water and ocean, so the fact that these aren't necessarily quote unquote rare, the chances of them passing over land and passing over populated areas is rare. So that's why it doesn't happen as often, and more often you see the pass of these eclipses and it's over the ocean. It's almost entirety over the ocean, or it may be wrapping, kind of coming to an end just as it's clipping some landmass to where it was out over the ocean, or you had to go to an island to see it. I know there have been some solar eclipses in the past that. All right, so this is.
This is a wedding in Arkansas.
Is that a bad omen now?
Yeah, I know.
Married in an eclipse?
We heard there are no bad omens with it.
Oh, that's right. Well, still, the myths maybe.
Yeah. So yeah, it's just.
This is Arkansas. Are these mass weddings? Or is it just one wedding?
Mass weddings.
It's getting dark. Okay, so they're getting into totality.
That's creepy.
Whoa.
Wow. And you can see the sky. I love that. I'm always curious. What does the sky actually look like?
Wow.
There they are.
At this point, I'm kind of more interested to see what it looks like on the ground as compared to just looking up at the sun. It's so neat to see that eerie twilight darkness.
I know, it's like it's like the sun is 400 times wider than the moon, right? And it's like 400 times farther, so it like lines up perfectly.
That's why
Did
they
you read
line up
that?
perfectly.
Yeah.
That's why they both look the same size in the sky.
It's like amazing. Like, how is that even? It's not like that anywhere else, I think, on any other planets in the solar system.
Exactly. It's a special gift for us, Earthlings, to get to see it. Yeah.
That is cool. It's cool to see, and then you heard from my sister-in-law how exciting it is. You don't think it's going to be exciting. It's like, okay, this looks like dusk, but it's dusk in the middle of the afternoon, and all of a sudden, this isn't it's just suddenly it goes to near black like that. Look how cool the sky is when you look away from the sun.
It's nighttime.
That's
it looks
incredible.
Like night. Now I can see why people back
People,
a
yes.
1,000 years ago were like, this is
Yeah,
it. This is
you're
the
right.
end.
Before you understood what was
Yeah.
going on, you can see why people were freaked out. Matter of fact, people are still freaked out about it, and we kind of understand how this all works.
Yeah.
And you know, lunar eclipses last so much longer. They can last for like a couple hours, you know, but these are so short with only a few minutes of totality. So it's like, that's
Right.
kind of nice for people in the past too. It's like, you know, in 5 minutes that you're good after it's happened.
You'd have time to start shooting those arrows up at the sky to relight the sun, just in case. They probably thought they were doing it right. They launched the arrows, a couple minutes later, it comes back, all right, it worked.
They're like, we got to keep doing
Mission
this.
accomplished.
Yeah. I wonder what it looks like here. I know probably not a big change. We're looking at the cameras right now. It looks
So
exactly the same.
are we at totality here? For, I mean, as
Yep.
far as our, yeah.
It's already done, huh?
I think we're a couple minutes past our peak,
Yes,
and looks like,
we didn't see it.
well, it's interesting though. I mean, that looks like a normal shot, you know? I
Yes.
mean, we only have 20% of our normal
True,
sun
yeah,
out
that's
there,
true.
and-
It's only 20% of the sun's light, and still looks like a normal cloudy day here.
Cloudy day, yeah. So it's interesting. You can't really
And
see
I
a big
noticed that
difference.
the sun is more active with a lot of prominences. Because in 2017 you didn't have that. You only had like one large prominence. And we had solar cycle 25 right now, and the sun is at its maximum or heading toward its maximum. So the activity was expected to be a lot more this time around.
Yeah.
So the solar corona will look a lot different now than it did in 2017.
No kidding.
Right. More impressive and kind of swirly for those who are in the path, right? Yeah.
So are astronomers expecting to get more data, more information from this eclipse than in ones past?
Oh yes, I mean,
Especially
we
the
have
one
more
in
modern
2017.
technology. Too,
Right.
than
Well, with the
2017.
but even from
Right.
2017.
Right.
I mean, it's fascinating to watch the sunscape, but even more so, I think, is now watching the crowds and what it actually looks like on the ground. This is again from Arkansas, where it again kind of looks like twilight, and shortly you'll start to get just that thin sliver of the sun coming back out, and then it'll be bright sunshine. It looks like much of the path of totality in Arkansas. I'm looking at satellites as well as what we're looking at on screen here. It looks like they've been under mostly sunny to partly cloudy skies across a good portion of the state. So most of Arkansas, at least within the path, should be able to see this fairly well. And then it'll be headed up toward kind of the southeastern tip of Missouri into southern Illinois, then kind of cutting across Indiana, then into northern and western Ohio before making its way toward the Great Lakes and then up into New England.
Right, and I think we're going to have someone from Niagara Falls talk to
Yes,
us.
who is on the Canadian side of the falls, that is going to talk to us a little bit later about what he's seeing. Another scientist, actually a local scientist, I think, believe he's a Ben Franklin grad.
Yeah, this is magnificent. I mean, it's very ominous, but can you believe what it looks like in that path of totality it's amazing. Where is this from? Is that Arkansas?
Yes, this is Russellville. If I
Okay.
can.
Yeah, you can see the kind of material coming off the corona there, off on the sides.
It's like maybe we have to change a filter on because as soon as that sunlight starts breaking back out, the cameras, I think, have to change filters. All right.
Okay.
Alexandra has something
And
for
now
us.
we're going to talk to someone from Stennis who's joining us. Travis Martin, thank you so much for being with us.
Thank you for having me.
And so it's all happening right now. What is it like for you to see all of these images coming in as the eclipse is happening at totality across all these huge cities?
I know, like myself and everybody at NASA and around the world, this is like exciting, so exciting. Here, the weather is not cooperating, but I actually love to see it on video elsewhere.
Yeah, and we've heard that NASA has a lot of plans for this eclipse. Tell us a little bit about that.
Well, I do know that they actually have additional science missions flying in the upper levels of atmosphere with instrumentation to take more data on this total solar eclipse. But all around the world, we are actually studying data all the time about the sun and to understand the environment around us and our solar system.
Have you ever been in the path of totality for an eclipse?
I have once as a child.
Wow.
it was still an awe-striking event, and I still remember it for the rest of my life. I mean, it is a sense of enlightenment. It is a special feeling to actually be in that cone of totality.
Wow. And so we've been seeing these images come in, and some of the common terms that we hear, like the Bailey's beads, the diamond ring effect, and things like that. Tell us a little bit about what we should look at as we see all these images coming in, or some special things that we might notice with these images.
Well, as you see, from the video you can see on the screen, it is actually the moon is moving away from the sun. So at that first moment, you would have seen that diamond ring effect, or that first sliver of light. But what I would like to have had been for myself is to be in that cone and actually see the atmosphere of the sun, just to see that halo effect around the moon. That is like really exciting and just an awe-striking scene to see in real life.
Yeah, and of course there's the other type of eclipse, the annular eclipse, where the moon is right in front of the sun, but there's still that ring of fire. Tell us a little bit about that, and maybe why you think it doesn't usually come with as much hype as this one.
Well, so the difference between this total eclipse and the annular eclipse is the fact that the moon's orbit around the Earth is not in a single plane. It actually is a little off-center. So a lot of the solar eclipses that happen all around the world are annular eclipse. It is a special time and a special position for the moon to be exactly in the position, that relative shape to cover the entire sun. That only happens, every so many years. So this is why it's really special. And it's very special because it's going to be a long time before this happens over the United States.
And we had one question coming in, some of these questions from students. Someone asked about the different types of space storms and space weather and things like that while we're talking about all of these kind of space events. Could you tell us a little bit about that, different types of storms that happen in space?
I wish I could, but that is not my specialty.
I gotcha. Okay, and then of course, besides the solar eclipse, there are often lunar eclipses, and that is actually coming up, a total lunar eclipse, much more, quickly in the future. In fact, we have one next year, I think. So how is that different?
Oh, that is more or less the opposite of what we're experiencing today, where the Earth will actually block the sun's rays on the moon, and so the moon will seemingly almost disappear for a moment in the night, and then it will reappear just in the same fashion that it's doing right now. It just won't be as bright.
All right, well, thank you so much. Joining us from NASA Stennis Space Center, Travis Martin, we appreciate your time today.
No, thank you.
And now we're going to go to Chris.
All right, we're going to be joined by another NASA scientist here just to kind of get some of the technical stuff that obviously we are meteorologists. We consider ourselves the station scientists, but there are folks that know a whole lot more about astronomy and solar astronomy that can kind of answer some of these questions a little bit better for us. And I believe we're joined via Zoom with someone. What are we going? Okay, we are looking live. Where is this from? Okay, Carbondale, Illinois. So this is in southern Illinois. Really, the totality for Illinois was only going to cover the southern tip. But Carbondale is a pretty large city, and now in totality. And again, as you have been watching steadily since this started to move into the United States, we saw it in totality in Mexico. And then it's been about an hour and a, not even an hour and a half now, we're already at Illinois. So it moves very quickly. You get those couple of minutes of totality in some of these larger cities, the larger cities that have been experiencing it, and then just as fast, you get the couple of minutes of what is seemingly twilight, and that little sliver of sun starts to come back up as the shadow continues to move, and then bright sunshine is back, and you need to put those glasses back on. Again, the only areas that could remove the glasses are within the path of totality, and only for those couple of minutes at its maximum coverage. So it, again, doesn't have a large window. Joining us now is Lance Landrum, who is a scientist with NASA. You are a NASA engineer. You're from New Orleans. You went to Ben Franklin?
Yeah, that's correct. Yeah, I went to Ben Franklin. I graduated in 2003, born and raised in New Orleans. Left when I was 18, and somehow I made it into NASA as an engineer.
So what kind of work do you do for NASA?
I work in launch services program, and what we do is we help to bridge the gap between spacecrafts and launch vehicles. So we do independent analysis of commercial launch vehicles like SpaceX's rockets or ULA's rockets, Falcons, Falcon Heavies, Vulcan, and we make sure that those rockets are going to be safe for NASA payloads. We also launch payloads for NOAA, Chris, which you'd probably be interested in. You know, we have a GOES-U satellite going up. Yeah, and obviously anybody on the Gulf Coast wants weather satellites up there to track hurricanes, storm formations. We also launch science and robotic missions like the Mars rovers missions. We have a big one coming up in October that's going to Europa, which is the moon of Jupiter. Yeah, so we launch all over the solar system, a lot of Earth-based satellites, but also Helio missions, as well as Mars and asteroids and Jupiter as well.
Well, you know, speaking of the Helio type experiments, can you speak on any type of missions that are being done during a solar eclipse?
That's a good question. I know that the solar eclipse is super special because you get a very unique look at the sun when the moon does come into that path of the sun's light. So there's going to be a lot of heliophysicists that are going to be looking for to look at the sun's corona, or the outer atmosphere of the sun, which you can only see during that total solar eclipse. We've launched Parker Solar Probe, which has gone as close to the sun as we possibly can, and we call it touching the sun. So there's a lot of really cool and amazing science that that NASA does for the sun and for all of the planets.
Okay, now you've left the comfort of New Orleans to head up toward Niagara Falls. You're on the Canadian side, I believe, right?
That's correct. Yeah, right behind me is Lake Ontario. We're in this wetlands area, and right across the lake is Toronto. It's this blue haze back there, and between Niagara, like south of Toronto, to Niagara is also in totality on the Canadian side. So we're lucky to be up here, and we're hoping that we get a little bit of clear skies, because right now it's a little bit cloudy, but it looks like it's clearing up a little bit, and hopefully we get a nice viewing here in a few minutes.
Yeah, what I could see from the sky behind you, it looks like you got kind of a broken sky, so hoping that you get enough clearing right at totality.
Exactly.
But
yeah,
have you ever experienced totality?
No, I have not. So this is going to be a first for myself and my family. We're really looking forward to it. It was a big endeavor to come up here, and I know there were some bad weather out in Texas. I had some of my NASA friends are traveling all over the country. I have a friend in Indianapolis. I got friends in Austin. I got friends in Dallas. Everybody's trying to view totality, because the next one, as you probably know, is not going to happen until 2044, and that's going to be very small. And then 2045 is when we're going to get a nice long one again.
Coming from NASA, how childlike do all of these engineers and scientists become for the build up to and then during an eclipse?
As my wife likes to say, we're all just a bunch of nerds. So
that includes meteorologists, so we're in the same boat.
Okay, good.
We're in the same.
Okay, great. So anytime there's any major launch, any comment or any close flyby of a asteroid or something, we all get super pumped. Lunar eclipses, solar eclipses, we love it all. And that's, I think, anybody that works for NASA, you want them to have that passion for space. And that's something that we try to do with the younger generation by, coming and talking to yourself, or going to schools and doing outreach events to talk to kids about space and science and technology and engineering and all the amazing things that are out there.
Well, we're looking at a live picture from Indianapolis, and they have just now gone into totality. So It is inching closer your way, and I'm hoping for those clear skies for you. What's one thing, or one of many things that you and your family, which is exciting here? You have younger kids, or are they as excited as you are about this?
Yeah, they were learning about it in school because they were starting to tell me, oh yeah, I want to see the diamond ring, or I want to see, like the corona of the sun and everything like that. So they were learning about it in school, and they're super pumped as well. And I think that they're going to go back and tell all their friends at school that, yeah, we got a day off and we got to see the total solar eclipse.
I mean, how great of a learning experience is this in real time across so much of the United States for kids to experience it, and then, to see science firsthand, not in a textbook, not even on the internet, but to actually go out and see it. How big is that for getting kids interested in STEM?
Yeah, I think that what's amazing is that now it's more and more readily available. There's more and more teachers out there pushing for engineering, pushing for the STEM classes. The opportunity is there, and the kids are really, really involved. And also you see a very diverse group of students that are crazy about space and love learning about it, because it's really, really amazing to think. And when you think about our Earth, and our Earth being the only place that we know of that can sustain life, and here we are on it, and we get to go out and look deeper into space to try and find other places that could possibly hold those building blocks of life. I think that that's truly amazing. And then when you bring that to classrooms, the kids are just blown away, especially when you start talking about the massive size of space and the Milky Way and our solar system. And we have some amazing missions that we've launched recently, like the James Webb Space Telescope, which helps us to look deeper and deeper into space and look actually further back in time. So it's really a unique opportunity to be a part of this right now, and hopefully the next generation is super inspired, and we're looking forward to spreading the message about solar eclipses, and luckily science and technology and engineering as well.
Well, we're at the peak in Indianapolis right now, so it is inching closer to you, so I want you to be able to go out and enjoy the rest of it. Lance, thank you so much for joining us. I appreciate it, and come back to New Orleans soon.
Oh yeah, thank you so much, Chris. Thank you for having me.
Thank you. All right, that was Lance Lunderman, an engineer with NASA, who actually is a rocket scientist, basically, with his family up in Niagara in Canada to see the totality. And as we said, it's already at Indianapolis, so that's in central Indiana, so it is nearing the Great Lakes. He was on Lake Ontario, I believe. And so it's getting a little bit closer to the Canadian border, and then eventually it'll pass through Maine, Vermont, Maine, and then kind of the Canadian Maritimes before kind of entering the North Atlantic, and then it's I believe it wraps up around there.
Yeah, and after they leave this Indianapolis shot, I bet they're going to go to Cleveland next, which is the totality happening in about 4 minutes.
And
so
look, you can see the sun. There
it is, that diamond ring.
Yep, there's the sun coming back out. So just that quick, and the glasses didn't go back on.
Yeah, Erie, Pennsylvania, 2:18. That's where it'll be. So it's moving. It's moving pretty quickly. We were talking about space weather earlier. You had asked him that. I think like a direct result of space weather is our aurora borealis, right?
Right.
So that's one thing that we could throw at you, some more facts, but no.
Right. And all coming kind of from those solar flares, those big bursts of energy that come from those spots on the sun's surface.
And the coronal mass ejections, and when they're directed toward Earth is when it can affect the power grid, GPS, satellites.
Yes.
There's always that fear of, the stronger ones and what they can do, but that's also what triggers the northern and southern lights, and so they're gorgeous, but with our reliance now on so much technology in space, it can become more of a hazard. So that's why these things, and you had heard, heliophysics, you might hear that term with regards to the solar eclipse. That's the scientists that study the sun. I mean, when you get into science, and this is something we tell schools often, this is a great job as a meteorologist if you're interested in science, because we tend to get to talk about all these different sciences.
Yeah.
Whether or not we know all about them, such as that black hole question I was given earlier, we may not be able to touch on all of those things, but it just opens up a wide range of fields that we get to discuss, and then also get to learn from. We get to talk to these type of experts and astronomers and NASA engineers and heliophysicists that study the sun, and all those type of folks that, again, you have to be, and you heard Lance kind of say this, you kind of have to be excited to get into one of these science fields, because it is more of a passion. We talk about the meteorology passion, but I guarantee you astronomers right now are very excited about this one. And
yeah. And speaking of learning, something I learned with this is that going into the future, there will apparently be more annular eclipses than total solar eclipses. Have you all heard this? Because the moon is inching farther away from the Earth, like an inch per year.
Oh, great.
So it's not like in our lifetime. I mean, we won't see any changes really. Good. But eventually, you know, we will have more of those where the moon is a little farther out and it doesn't quite completely eclipse the sun. It's right in front of it, but you can still see the sun, you know, in a circle around it.
So we lucked out.
I guess, yeah, but I thought that was kind of interesting. I didn't know the moon was really moving around.
Yeah, that is correct.
Yeah.
Because at some point we're not going to have any more total eclipses.
Oh, God. When?
Not tomorrow, but
we're talking in a
millions of
distant future, though. It's not anytime soon. We're talking millions of years.
But that is interesting. That again is probably something that can be probably calculated to a decent accuracy at this point, as you kind of figure, you know, how fast it's moving away and the sizes and the
I think I read it. After the year 3000, it's hard to predict because the Earth's rotation kind of fluctuates because of the tidal friction with the moon. So can you verify that? Is it harder to predict after the year 3000 because of tidal friction with the Earth's rotation? I don't know. I mean, I read that somewhere.
Possibly. That's a good question.
Yeah, that would be something to ask one of the astrophysicists.
But you know, speaking of space weather early there, once the eclipse is over, people have these solar, eclipse viewers. Well, don't throw them away, because you can still use them to view the sun on any day to see sunspots.
Oh, cool.
So if you go to like a website like spaceweather.com, they give you daily updates, and when there's a large sunspot, usually around three Earth sizes or so large, you can actually see it just with the viewer.
Wow.
And with the active solar cycle 25 that's going on now, you can actually see that more often now with a lot of sunspots just with the viewer.
Well, that's good advice, because don't throw these away. These are actually useful for
they don't
a lot
go
of
bad.
other. Right. Yeah, that's true.
As long as they're kept in a safe place, you know, like in a little plastic bag or something where they don't get scratches on them.
Yeah, save these for the next eclipse and for other solar events that you can see, and when you should not be looking at the sun ever, but just for something interesting like that. I believe we're looking at Cleveland now, so they are in totality. So just a few minutes ago past Indianapolis, now in Cleveland, so it's right at the Great Lakes, and so our friend Lance in Niagara will be seeing it shortly. And hopefully he'll get enough clearing. Even if he doesn't and he's not able to see it, you're still going to get that twilight glow of the land as it passes over Niagara into Canada.
Yeah, and by the way, Todd Danos on Twitter did send me a picture where from New Orleans you can see the eclipse. I mean, it's not like super impressive, but he found a tiny break in the clouds.
Oh, yeah.
I'm looking at it here. You can see it on Twitter. And
well, he found that one little break.
He found it. I'm very, impressed. So
and you just have that, so follow Alexandra's Twitter. It's we're all now gathered around our computer looking at a little crescent sun.
There it is.
Like we haven't been looking at that all afternoon long on air or on our streaming. But that's that's as good as it's going to get here. That was it. It's over for us.
Yeah, it looks like a little moon almost the way it comes through. But
I think I read that more total eclipses happen in the northern hemisphere. Did you read that? Did you see that?
Interesting.
Yeah, I think it's because of the lopsided elliptical orbit around the sun. That's that's why. Our lopsided elliptical orbit around the sun is why we get lucky in the northern hemisphere and see more total eclipses.
Interesting. And of course, there's a lot more land and, you know, more people in the northern hemisphere anyway. So a lot of people, you know, able to see it more than the southern. So that's convenient.
I'll have to share this on social media in a moment. My sister-in-law from Austin sent me a picture of the diamond ring effect.
Beautiful.
I mean, it's something we've seen, but I think it's just something else to see experienced by someone. And she actually, I thanked her on, I texted her and thanked her, and she goes, "I'm sorry, I completely zoned out. I was so enthralled by what was happening, I forgot we were on air." And I said, "No, that was the best part. It was great to hear your, genuine reaction to it going dark like that." And she said, "Yeah, we've been talking about, they've been, obviously the folks on air in Austin have been talking about it, but she didn't really know what to expect until it was happening."
Yeah, and very kind of her to share the time with us.
Right, exactly. She's watching it out in the parking lot with everyone else in her complex. But it's interesting how they handled it. It was almost like an evacuation of, if you can work at home, stay at home. Schools are canceled. UT was closed, advising people to stay off the roadways. I guess it was just something, and I guess, to be honest, if you're driving and you think it's happening, you may be more inclined to try and glance up and not paying attention to the road. So
And
I guess there's that.
States of emergency.
Looking
for
at the
just
solar
people.
corona here, many people don't realize you're looking at the hottest part of the sun. That's the solar corona.
No kidding.
It's over 1 million degrees. And so NASA has the Parker Solar Probe that's touching the sun right now, trying to study, get answers for why that is. Why it's got to do with magnetic field lines, but they're trying to find out more information on why the solar corona is hotter than the surface of the sun.
No kidding.
Yeah, that's.
So you say it's quote unquote touching the sun. How close is it?
It's
to get any kind of accurate data.
I don't know the exact distance, but it's the closest any spacecraft has ever gotten to the sun. And it's specially made to do so. So all the instruments are actually staying cool on the other side of like a giant shield.
No kidding.
There's like a big shield, and it's made out of certain material. And it's actually going to get closer and closer over the next few years.
Really?
So right now it's at its closest as any man-made craft's ever been. It's going to get closer and closer until it makes its closest within, I forget, within the next few years.
I don't know if a lot of folks realize we had a space probe near the sun.
Parker Solar Probe.
That is really interesting.
It was launched about 2 or 3 years ago.
Okay, and I'm sure our friend Lance probably was involved with that. It sounds like he does a lot of those.
Yeah.
All right, now this shot is from New York, so making our way off to the northeast, and looks like it's almost at totality there. I know Buffalo starts at 2:18, so right around now for totality there. So happening in New York now.
I was trying to get a picture from my family in New Jersey, but but they're not, their camera, I would imagine they're taking it without the protective lenses, which is not advised. Don't do that. Right. They're probably taking it just without anything to protect their phones, but the picture doesn't look so good. They also only have about 80% coverage of the sun there.
Like us.
About exactly like us, but they luckily have mostly sunny skies today, so they can actually see it.
Yeah, that's cool.
But I wish I had a better picture to show.
Yeah, and they say part of the reason for not using your phone is because it's higher in the sky than we normally would take a picture, like at sunset or sunrise, where it looks so pretty. Mm-hmm. But you also have a lot more of Earth's atmosphere to kind of look through, so that's not as bad for your phone, as just pointing it straight up at the top of the sky.
Yeah, true.
But yeah, a lot of people do it. I know I've actually done that before, to take pictures of like sun halos and rings around the sun and things like that. Maybe I have an old phone that isn't affected as much or something.
Well, or it may be enough of a filtering of the high clouds that it's not, that it's not as direct on your phone.
Right, just like pointing it up at a clear sky.
And maybe if you, do it quick enough, then it's not so bad. But,
yeah.
Maybe you won't try that next time.
Yeah.
Just use Alexandra's old phone for all your sun pictures.
It did fine with the sun halos.
I think it's been pretty neat. I'm also looking back at I'm going to want to pop up Max 2 again. I've been kind of watching on a wider loop of the United States of the shadow passing across the nation, and just how fast. I believe this loop may be, well, since this morning, but just how quickly that shadow moves across the sky, which is really neat.
Actually, I think we got another person on Facebook, on our WWL Facebook, also saw it between the clouds down the bayou today. So.
Oh, really?
Yes. So
I'm glad some folks got to see it. We've been talking about it for a few weeks now, and once we started to get that idea of we would be under mostly cloudy skies, it wasn't looking as promising here, but.
Yeah. And also just looking at our temperature, just before 1 p.m. we were at 76, and then just before 2, so at the maximum we were at 74. So our temperature went down 2 degrees just from that, obscuration of the sun. So interesting to see. Not as much as in totality, where I saw it could be anywhere from 5 to maybe they were thinking 10 or 15 degrees maybe.
I'm sure with an area of low humidity, it would be more substantial.
Yeah. I mean, we got 2 degrees.
You get, well, that's about all we can expect.
Yeah.
Well, you cut down that for 2 minutes, 4 minutes, however long it lasts, that incoming solar radiation. It would affect the temperature, and with low humidity, it would probably be more responsive.
Yeah.
True. Yeah.
I know earlier we were teasing possible Jeopardy, but I guess we ran out of time for that.
I think we're out of time
we were going to do trivia.
For our trivia questions.
Oh, man.
Were you looking forward to being on the spot?
Yes, I was.
Having used that buzzer?
Hey, look, I was the one on the spot with some of those student questions that I thought we had answers for, but apparently someone in the newsroom thought
those are tough.
all right.
So thought I would have it.
I mean, those are some difficult questions. I haven't thought about that stuff since I was a kid.
Yeah.
But you know what
but
we're talking about kids and being a great learning experience. It just shows you how inquisitive they are. And I know all of us have done countless school talks. There are certain ages that they are just really curious about science, and they will have the sometimes wildest questions that are very valid that we maybe have not even thought about.
Yeah, they're genius questions.
All right, coming up is something from Twitter. We're about to see an image. Let's see.
Oh, jeez.
Oh my.
Is that from the Weather Service?
That's so funny.
So I believe the Weather Service may be apologizing for the cloudy skies. You know, people blame us for the weather. It really goes back to the Weather Service.
Yeah.
And maybe it has to do with the fact that they moved the radar. Maybe if we had not moved the radar, we've been under sunny skies. So
is it Hammond's fault?
It might be Hammond's fault.
Is that here? No, that's not here.
Is that here?
No, that can't be.
Oh, Niagara. Okay. Well, they're kind of dealing with the cloud cover too. I don't know if that was here earlier. Maybe we got a little bit of a break in the clouds, but I was looking through some of the cloud level forecasts through the afternoon, and if we had just been high clouds, we would have been okay, because that actually would have acted as a filter. But as soon as I saw the low cloud forecast, we started getting showers, thunderstorms on radar, I knew it was going to be a bit harder to get that.
Yeah, that was disappointing to see. But the next one, again, 2025.
Yes.
Now, what are the next ones that are closer of totality to us?
For us, it's 20. There is one in 2044, but that's just a part of Montana and into Canada. So that one will be total.
Yeah, I'm not going there.
Yeah, tiny bit of just the U.S. covered with that one. The real next one is 2045 for the total solar eclipse. That one will go from places like Colorado Springs over Arkansas. That one will hit Jackson, Mississippi, and then on toward Destin, Orlando, and Miami. And then if you can wait a little longer to 52, that's the one where it's going to be pretty close to us. Grand Isle, Leeville. New Orleans will actually be like 99% totality.
Wow.
So I think you need the 100 to get all of those effects, but it'll be really close, very much more dramatic, I think. And then that one also hits Pensacola, Destin, and then eventually Savannah, Georgia. And in 2078, it's right over New Orleans. However, if you want to get into eclipses, not of the solar kind, but lunar eclipses, we have one less than a year from now. That one will be March 14th, 2025, a total lunar eclipse in New Orleans, and also the following year in 2026. So 2 total lunar eclipses, but of course the solar is,
a little more impressive.
Very impressive in that path, especially of totality, of course.
So this is in somewhere upstate New York, Tupper Lake. So kind of the Finger Lakes region, I would imagine, at totality now. So just amazing how just within our broadcast here, we've gone from it in Mexico to now upstate New York, and shortly kind of exiting the Northeast.
And David was nice enough to bring us eclipse glasses. However,
they are definitely not needed today.
Definitely. For some people.
But thank you for staying with us. That was all great information.
Yeah, I appreciate it, David.
All right, we're going to kind of wrap things up here, or
I know.
You know, we had
Funny, yeah.
big plans for this show. Had we had sunny skies, we'd be able to at least see, again, at 80%, not quite totality, but hopefully that got a lot of folks more interested in astronomy and science.
Absolutely. Yeah, thanks for watching.
Thank you for joining us. Can the producer just do this for us? Could you just tell us? We're going to have a whole lot more on our YouTube channel, social media, as well as this will be constantly broadcast on our streaming service, WWL Plus.